We're going to do another LINQ challenge now, and this challenge is all about sorting a list of people into order by their age. And you can see here the data that we're going to be using as the input to our challenge, which is actually a list of football players. It's got their name, then a comma, and then their date of birth in a day, month, year format, and a semicolon, and then on to the next one. And so at first glance, this looks like a fairly simple problem, although what we want in the output is not their name and date of birth, but their name and age in years, okay? So we'll need to turn date of births into ages along the way. Now, as with the other LINQ challenges, why don't you pause this video now, load up LINQPad or Visual Studio, and see if you can come up with your own LINQ pipeline that will take a string of names and ages like this and sort them into ascending age order and show their age in years in the output. Okay, did you try it? Well, let's carry on anyway and have a look at how we might solve this with LINQ. Now, the first few steps we need to go through are probably quite familiar. The first thing I'll do is split on a semicolon, and when we run that, we can see we've got 6 people's names and dates of birth. And then I'm going to use select to transform each of these people's names. And so for each of these strings, I'm going to do another split, this time on a comma. And so now you can see we've got an IEnumerable of arrays of 2 strings, each containing the name and date of birth. So the next thing we need to do is parse the date of birth, because it's currently just a string. So let's do that with another select, and we're going to say that we want a new anonymous object where the name and n in this lambda is just a 2-element array, so n0 is the name, and we'll trim it because we've got some leading white space. And then the date of birth we need to parse, so I'm going to say datetime.parseExact. I'm going to take the date of birth string, which is the second element in these arrays, and I'm going to say that it's in day, month, year format. And then I need to pass in a culture info, and we'll just say invariant culture for now. Okay, so let's have a look at what we've got now. And we needed to trim off some leading white space here. And we've successfully parsed our data into an IEnumerable of anonymous objects containing the name and the date of birth. Now we can order it by age, and we can do that by saying order by descending. And we're ordering on the date of birth descending. It's descending because the youngest person has the most recent date of birth, so it's the highest date of birth. And so we can see that in this data, Luke Shaw is the youngest, Kelvin Davis is the oldest. But we're not quite done yet, because we said at the beginning that we wanted to show the player ages in years in the output. So I'm going to select a new anonymous object, and the name can just be passed through from the previous anonymous object. But then what about age? Well, we could say, let's see if we can work out a way to calculate the age. What about if we say datetime.today.year minus the player's date of birth.year? And when we run that, we get ages for these players, but they're not actually correct. There's a bug in this code, and that's because that's not actually how you calculate somebody's age from their date of birth. So how are you supposed to calculate someone's age? Well, this is exactly the sort of question that Stack Overflow is great at answering. And here you can see that somebody has helpfully given a C# way to calculate someone's age in years correctly and taking into account whether their birthday has already happened this year or not. So we can take this code and we can go back into LINQPad, and we would now need to create a slightly more cumbersome method here in place of our original lambda expression. So we can paste this code in, and the birthday is n.dateofbirth, and then we're going to return a new anonymous object containing the name and age, and we'll need to change this one as well. And so we've taken this code, and when we run this now, we have the correct ages, and you'll notice some of the players' ages have changed there because it's now taking into account whether they've had their birthday or not this year. So now we've solved our problem, but have we done it in a particularly elegant way? What you can see here is that we've now got this rather cumbersome looking function sat in the middle of our LINQ pipeline. So what can we do about this? Well, there's a few things we can do. One of the things is we could pull this out into a helper method. So let's switch LINQPad into C# program mode, and all this does is it allows us to declare our own methods and classes. And I'll also need to put in a dump method here on the end of this statement so that we can still see the output. But let's declare a static int getAge method taking a date time, date of birth. And we can take this, we can return the age and use the date of birth parameter. And now this allows us to refactor this stage in our pipeline back to a simple anonymous object again. GetAge with the date of birth from the input anonymous object. Let's just run this and we can see we get the correct answer again. And so what we've done here is we've taken the specifics of how to calculate an age out of our LINQ pipeline. We don't need to see that. When we're looking at the LINQ pipeline, we just need to know that we're getting someone's age. We don't need to see all the details of how it's done. Is there anything else that deserves to be cleaned up? Well, I think we should also try and clean this up. The parsing of the date of birth is a little bit messy. Now we could just create another function like this. So static datetime parse dob, taking a string of a date of birth, and then take this code and move it into our method and return the parsed version of our date of birth string. And this allows us to say parse date of birth on N1. Again, we're pushing some of the low-level implementation details out of our pipeline. Now, maybe you don't like creating one-liner functions like this, as it's now taking up several lines in our source file. Is there a way that we can make this declaration a little bit more compact? Well, there's a couple of options. One option is that we can say we have a func that takes a string and returns a date time called parse dob, and then we can do that, and that gives us a method that we can use in line. Or there's another option if you want a one-liner, and that's to make use of C#6's simplified method declaration syntax. So I can actually get this whole parse dob method onto a single line of code like this. And of course it's up to you whether you prefer this approach. By the way, we can't use var here. Unfortunately, the C# compiler doesn't know whether the thing on the right is a func or an expression, so we actually have to specify the type, which does make this a little bit cumbersome. But what we've done in this refactoring of our solution to this LINQ challenge is simply cleared out a few of the lower level implementation details, such as how to calculate an age and how to parse a date time, to make our pipeline a little bit easier to read. So let's delete this func and we'll make use of the static method we declared down here. And we'll leave this challenge here. There are a few other things we could have done to make this even more readable, but the key thing I wanted to demonstrate here is how simply breaking out little bits of code into helper methods can make your LINQ pipelines much easier to read. Let's move on now and do another LINQ challenge, which will demonstrate more ways we can improve the readability of our LINQ pipelines.